All right, so in this module, instead of trying to determine the indices of a direction, we're going to look at how we sketch crystallographic directions. So basically the opposite. All right, and so just like we think of direction sketching as the opposite, the operations, the procedure that we do is the same. It's the reverse. And so what we're going to do is if we have a given set of indices here, 431, we know it's a direction because it's got square brackets. So the order of operations here, the procedure, is going to be the opposite of what you saw. The first thing we're going to do is extract those indices and then write them in terms of the unit cell dimensions A, B, and C along the X, Y, and Z directions. We're going to adjust the indices in this case so that they actually fit within the unit cell if they do not already. And then we're going to draw the endpoint of that adjusted indices, and then we basically draw a line from the beginning to the end, so from the origin to the endpoint. So basically, we'll kind of see this is the reverse of what we've just done in the previous modules. All right, so let's do this. So we've got the indices, the square brackets 4, 3, 1. So let's extract them and put them in terms of A, B, and C. So as always, I use this table. If you want to do that, that's fine. If you don't, that's fine as well. But I would definitely try to find a way to show your work. So I'm going to have 4A, 3B, and 1C. So that's the first step that we have. So the next step is to adjust the indices to fit within the unit cell. So if you're asking yourself, how do I do that, or what do I do? Keep in mind that the unit cell, right, each one of these directions is to get to the end, right, of a corner, you're going to go in one unit of that length, A, B, or C. So if I have numbers greater than 1, so 4 or 3, that would put me well outside of the unit cell, right? So for example, 4A, this is 1A, this is 1A, so I'd have to go 3 more units, right? So it's not going to be within the unit cell. So what I need to do then is, just like we adjusted to have the smallest integers, here we want to basically do the opposite, and we want to adjust so that nothing is greater than 1. So it either has to be equal to 1 or less than that. And so if you kind of look at these numbers, if we want to make everything less than 1, 4 is the biggest number, so we're going to have to take care of that one. And so we do that by dividing by or multiplying by 1/4. So that would give us 1, and then 3/4 and 1/4. And so everything is going to be 1 or less, and so it's going to fit within the unit cell. So again, we're trying to do this just so we can draw it nice and neatly within the unit cell. So basically what we're doing with these adjustments is we're basically changing the length of the direction. And because we know that the direction is infinite in length, this is more of a just convenience to get it to within the unit cell. So you can draw it longer if you want, right? You could do 4, 3, 1, but you're going to have to make a much bigger unit cell or multiple unit cells to make that happen. So we might as well just scale it. And that's what we're doing here. So we can always scale directions, either up or down. All right, so we've adjusted. And so now we basically draw the endpoint. So our endpoint we know is the indices 1, 3/4, and 1/4. So we basically find that point, right? And so to do that, we go 1 length of A, 3/4 of the length of B, and then up 1/4 the length of C. And so that puts us right here. And this is on the front face of the cube because we're going 1 length over, 1 length X. So that puts us on the front face. And then I'm showing kind of where it is by putting these dashed lines so you can see that it's 3/4 of the way over to the right, and then 1/4 of the way up this front face. So that's where that point is. So we've drawn the endpoint, and now all we have to do is draw an arrow to represent the direction from the origin to the endpoint, right? Because again, the direction is denoted by the difference between the endpoint here and the beginning point, which we always take to be the origin for convenience. So that's all we have to do for this direction. And so when you do this yourself, again, it's often difficult to see because we're dealing with a three-dimensional space, but we're doing it in 2 dimensions. If you don't show any sort of work or scales here, like what these links are, it's often very difficult to determine where the direction is going. So if it's not obvious, like one of the directions here or here, right? Then you often want to show your work if it's not going to a corner or an edge. So I would recommend always showing your work if you want us to be able to know where that direction is.